In this video, we're going to take a look at stoichiometry, which basically means looking at a balanced equation and using its ratios to solve problems. So we're going to take a look at this balanced equation. It's methane plus oxygen yields CO2 and H2O. It's definitely a combustion reaction. And so what we're going to do is we're going to take a look at first the ratios. So basically this tells us that if I have 1 mole of carbon of CH4 and 2 moles of oxygen, it will produce 1 mole of carbon dioxide and 2 moles of water. So we can use those ratios to solve various problems. But usually what we start with isn't moles. Usually what we start with is grams. And so what I'm going to show you first is what's called a gram to gram conversion. It's 80% of what we do is that. So we're going to start off with 100.0 grams of CH4. And what we want to go to is, in our first example, is grams of water, H2O. Okay, so always what you want to do is put down what you're trying to find. That's going to be my step 1. My step 2 is put down what you're trying to find. Put down what you're given, what you're trying to find, and then put this line in between. That's good. That's our division line for sure. We're going to use dimensional analysis to get there. So there's a few things you have to remember. 1 mole equals molar mass. And molar mass you get from the periodic table. So I've already added up CH4, ends up being 16.05 grams. Again, 1 carbon, 4 hydrogens, and then put 1 mole of CH4 here. First step is always to get to everything to moles. And the reason why we do that is because that's what the balance equation is written in. And the balance equation is telling us what the ratios are. So this is the new step right here. I'm going to use the balance equation to basically say for every 2 moles of H2O, I'll need 1 mole of CH4. And again, that's from the balance equation, these numbers right here. And then from there, we can go from moles back to grams. And the molar mass of water is 18.02 grams. Now, make sure we want to check, make sure that we've canceled everything out. So, grams will cancel out, moles cancel out, moles of H2O cancel out, and you're in grams of H2O. Now, you can stop when this happens. When what you're left with is what you're trying to find. Okay, you've done it. You can stop there, you can pick up your calculator, and you can get your answer. It ends up being that our answer is 224.5 grams. It's 5 sig figs, so that works out. Okay, so let's see if I wanted to figure out oxygen. So let's start off with 100 grams of CH4 again. And this time we want to go to grams of oxygen. Now, it doesn't matter what side of the arrows your numbers are on. It works exactly the same way. You'll see that this first step is very redundant because you always want to get to moles. Whatever you start with, get to moles. Okay, and then you're going to do 2 moles of O2 and 1 mole of CH4. Again, that comes from the balance equation, nothing else. And then we're going to go from 1 mole of O2, and we'll get 32.00 grams of O2 up top. Again, we want to check, make sure everything cancels out. Moles of O2, and we're left with what we're trying to find. So this is going to equal for us 398.8 grams. Again, 4-6 pigs. It sounds like quite a bit. A lot of times for gases, we want to use liters. Now, one thing that we talked about when we talked about gases before is that 1 mole of a gas at STP equals 22.41 liters. And STP is 0 degrees Celsius. I'll write this down here. 0 degrees Celsius and 1 atm. So that's STP. So we can do this problem. We can find liters of O2 pretty easily doing exactly the same thing. So we can go ahead and do all this. And it's going to write down pretty much exactly the same thing. And this time I want liters of O2. Now, gases and conditions aren't necessarily at STP all the time, and we can sort of figure out how to do that too. We can use PV equals nRT, and we'll get to that problem in just a second. So we're going to set up this problem exactly the same way. So, and then we want to go 2 moles of O2 again, 1 mole of CH4, and this time, this last step is going to be a little different. 1 mole of O2 at STP is 22.41 liters. So everything should cancel out because it's the same thing as above, and we're left with liters of O2. Just so happens that our liters of O2 are 279.3 liters. Okay, now what if it is an STP? So this is what you need to do. You need to pretty much stop right here. You need to find moles. Because once you find moles, you can use PV equals nRT to find liters. So let's just sort of stop here. Let's do the same problem. Let's get the answer right there. Okay. And if I stop right there, the answer to this is 12.46 moles of O2. If I just stopped without doing that last step, it's 12.446 moles. And let's say my new conditions are at 20 degrees. Oops. Let's say they're 20 degrees and 0.95 atms. Well, in this problem, what we can do is say, well, I know that PV equals nRT. I know that my volume, if I was going to solve for that, is nRT over P. And I know that this equals 12.46 times 0.0821, that's the gas law constant that's on your resource sheet, times, and then for 20 degrees, it'd be 293.15 Kelvin. Remember, you have to add 273.15 to this all the time when you're dealing with gases. I'm going to divide that by 0.95 atms, and we get 316 liters. So if you compare these two numbers, we have this guy at STP, this volume at 20 degrees and 0.95 atms. They're close, but they're a little different. So those are the different types of stoichiometry problems. There's more, but hopefully this will give you a good start on that worksheet.